Hello, I'm David Underdown, a Senior Digital Archivist at the National Archives in the United Kingdom. I'm going to be talking about DiAGRAM, the digital archiving graphical risk assessment model, and how we're starting to rethink our practice by quantifying digital preservation risks. So we were particularly asked to address the conference theme of the impact of feasibility on decision making. So framing that, let's consider that digital preservation is typically taking place in organizations with quite constrained resources. So we have to determine how to use the resources we do have in a situation where there are almost certainly many more actions we could take than we can currently resource. So there can be a danger of analysis paralysis. We become overwhelmed by the choices available to us, and it becomes or seems almost easier to do nothing than to actually choose where to start. So we think, all of the things being equal, that place to start is with the possibilities within our resource capability that would offer the biggest reduction in risk of loss or damage to the materials in our care. And on the flip side of that, there's also an advocacy opportunity. If we're evidencing things, we might discover that the most effective things we could do would actually exceed our current capacity, whether that's because it's too expensive to purchase equipment or it needs cooperation from another department that's not really under your control. But if we can provide good evidence of the need, then we can create business cases or otherwise advocate for the additional resource. And we think, perhaps this is actually the missing link within the three-legged stool model of digital preservation that really allows us to quantify our need for resources. So risk modeling and the Bayesian network approach we've taken. So risk modeling certainly isn't a new idea in digital preservation. Go back to John Conway's 1996 report for CLIR. David Rosenthal and others also had a 2005 paper going into risk modeling, and there are more general models such as the spot model and Drambora, or more specific ones looking at storage and so on. And that really become the dominant mode of approaching looking at digital preservation right then. We can also consider the NDSA levels of digital preservation as a risk mitigation strategy, but we can't tell at the moment if, for example, we're moving from level 1 to level 2, looking at across the functional areas in there, does a move from level 1 to 2 give us the same reduction in risk in each functional area? Or then does moving then from level 2 to level 3, is that the same again, or does it give it a bigger jump? So our work really started with a bit of a hunch from our digital director, John Sheridan, that this Bayesian approach would be useful. And so in 2017, a small group of us at the National Archives started doing some initial research to validate the concept and see if it was likely to be a reasonable way of moving forward. My original degree was in maths, so I had some familiarity with the concepts. So expertise in various ways was an important part of this. As a community, digital preservation, we don't seem to have been collecting, or at least not sharing, specific data about quite a lot of potentially very important areas of digital preservation practice, and most specifically perhaps failures over time. So the fact that within the Bayesian field there are rigorous methods for converting the expertise and insight of practitioners to actionable statistical insight seemed a very important aspect. However, it was also clear that we ourselves didn't have the expertise to put those methods into practice, so we could do with some assistance in applying these methods. Fortunately, the UK National Archives, we had existing contacts with the Turing Institute, so we started to work with one of the Turing Fellows, Professor Jim Q. Smith, who's also a member of the Applied Statistics and Risk Unit at the University of Warwick. So both the Turing Institute and ASRU have remits to help develop the application of methods rather than just pure research. ASRU also have research interests in integrated decision support systems, IDSS, which is really about making those models useful and easy for practitioners to incorporate into practice. So we could have just moved forward and built a National Archives model, but that would have been more limited and perhaps restricted view of what digital preservation is, harder for others to apply. So we looked for partner archives to collaborate in building the initial model. And the UK has in the UK, the National Archives has a formal leadership role for the archive sector in the country. So it made a lot of sense. On the one hand, this meant we needed more funding to help all these people work together, and we assumed we'd be bringing people together in person, but as you might imagine, that hasn't quite worked out. But it also made it easier to obtain funding as we could demonstrate a likely wider impact for the work. So to build the network, both in terms of the bringing experts together and the Bayesian network, we held a series of workshops, initially working out the risks for them that would form the model. Some things we potentially do affect it, but are a bit more outside our control. So it was a matter of finding the sensible bounds for the risks we were going to include, and then the interdependencies between them, how they affect each other. Then with that, in some cases we could find genuine hard data to help us with aspects, and for the areas where we couldn't, then we used a formal elicitation of the expert judgment using the IDEA protocol. So IDEA is investigate, discuss, estimate, and aggregate. It's a process designed to reduce various biases that are known to affect estimation. So when we're undertaking elicitation, then for each of the sort of questions that will be considered, information is sent to all the experts who will be taking part. So they have time to consider it. And there's a facilitated workshop with initial discussion. This is to try and ensure that questions are understood in the same way by everyone. And the experts then make an initial round of private estimates, considering the upper bound of possibility, the lower bound, and then the median, the best guess, what they think is actually most likely to be. These estimates are then shared anonymously in the form of range graphs, as shown on the right of the slide. So we've got experts listed up one side, just identified by a number, and they're giving their estimates in the form of the range there. So that's about a number of files out of 1,000 that might be affected by a particular digital preservation issue. We can see there's quite a lot of variance. Expert 14 in the sort of purple up on the left is a long way over to the left compared to virtually everyone else, and very tight range, but doesn't overlap hardly with anyone except expert 4. So there's then a discussion phase. People can look at these without sort of having to reveal who they are, but they can talk about why they think it might have been higher or lower, and why some, from their experience, why these things are better. The aim isn't to achieve an absolute consensus, but just to, again, to try and make sure that everyone is understanding questions in the same way. So after that discussion, there's a second round of estimates, which people can either stay with their initial estimate or tweak following that discussion. And then once those are all submitted, then the scores are, these ranges are aggregated into final overall scores. Among the questions can be some calibration questions. So these are things where the answers are actually known or can be determined, and these can be used to weight the input from each expert depending on how they've performed on the calibration questions. If they show that they do very well on the calibration questions, then the assumption is they're going to be good on the unknown areas as well. So we built this actual network. We've got 9 input nodes along the top, colored green if you can see that. Then in the white nodes in the middle are things that all come together and influenced by more than one of those input nodes typically, or go on to influence other things in interrelated ways. And then at the bottom, we've got the 2 output nodes, which is what we're actually kind of scoring on as the real risks to our collection. So we feel those outputs are renderability, that in the future you'll be able to have a representation of the original file that's sufficiently useful. That includes being a faithful enough representation of the original. and having intellectual control over all the materials. So that's about being able to identify precisely the thing you want to be able to find and produce, and understanding how you can legally make use of it through conditions of use. So we can see how technical skills has an input, it's the middle input, and influences both obsolescence of storage, the tools will need to render particular files, which obviously depends on the format they're in as well, and the technical metadata that is there to assist in renderability. So the diagram tool. So we can incorporate the statistical data we've gathered into the network and produce the full network. And we need to get the full integrated decision support system diagram. We need some sort of visualizations of the risk for your particular archive, being guided through how to complete the input nodes in a hopefully repeatable way and a way that would make comparisons between archives potentially useful. And then ways of creating scenarios to investigate and model what happens to your risk if you were to change particular aspects. So the input questions now use combinations from things like NDSA levels, DPC RAM, DigiCurve, skills, matrix assessments, wider questions about information security and knowledge of your policies, proportions of material you have in the archive. The need for this kind of guidance particularly became clear from feedback of our initial prototype released in July. We did a series of online workshops to allow people to play with it. And we had 6 weeks from the end of August into mid-October where we undertook focused development to improve the guidance and visualization aspects, had 2 formal rounds of user testing within that. So now we have the visualization. You can create your baseline model, create scenarios by changing answers to investigate how your risk levels change. And there's also advanced customization option, which allows direct changes to the underlying probability tables if you're more confident in what you're doing. And then once you've done the models, you can delete models, change names, create further scenarios. You can always choose where you're starting from. So you can start from your baseline model. You can start from an existing scenario. So you can kind of build cumulative models to show how you build a whole program of work. And you can download reports, which are PDF, to be able to immediately share with someone, or you can have a CSV so you can do further work, perhaps combined with the financials. And there's a kind of binary download file as well, which allows you to kind of keep exactly what you had and come back on another occasion, upload, and do further work. Normally, there's nothing stored within the system. There's no login or anything. So this means we can't see what you're modeling, but if you want to be able to come back and carry on from where you left off, you do need to make that download. So we'd love you all to try it. Currently, it's at https National Archives shiny@.io/diagram-jr. So https://NATIINYALARCHIVES.SHINY-diagram-jr/. And we look forward to questions afterwards. Thank you.